In this video, I'm going to walk you through an example of using this formula for finding the future value of an ordinary annuity. If you haven't already, pause the video to read the information here at the top. The things that I want to discuss about this information up here that tells us what really is this formula, how does this work, I would just recap down here at the bottom. So A is the future amount of the account of the annuity. R is the amount that's being invested in a regular payment. Usually that's a monthly payment, but it doesn't have to be. It could be weekly or something like that. But it's just a regular investment in dollars. R is the interest rate written as a decimal. M is the number of compoundings in a year. And N is the number of periods. Another way to think about the number of periods is if we multiply the number of compoundings times the number of years, then we get the total number of periods of compounding. So let me show you an example of how this works out. So here's one of the examples from the homework. It may be similar to your question number 5. So pause the video to read the full problem statement. The first things that I want you to do is identify all of these parts. What do you know? We're going to list it so that we would know exactly how to place it here into this formula. And then what we don't know is, again, what we're trying to answer, that question that we're trying to answer. So see if you can identify these different parts. Because the question is asking, how much will she be able to save? That's like a long-term or future value. This is A. This is really the question. We do not know the future value of the account, but that's eventually what we're going to solve for. We're told that each month she deposits $110. So that's her regular, I shouldn't say payment amount, but regular deposit amount. R is the interest rate written as a decimal. So here it's written as a percent. That means I'm going to need to move this decimal 2 places to the left. And in my formula, I'm going to refer to it like this, 0.00103. M is the number of compoundings in a year. Now, it doesn't explicitly say this is a number, but it does tell us that this is a monthly interest rate. So that means that we're compounding interest every month, or in other words, 12 times a year. N is the total number of periods of compounding. If you recall, we could calculate that by doing M times the number of years. So in other words, 60. So all of this information here is going to go into this formula. Now, one quick thing I want to notice is that A is what we're being asked for, and notice that A is already isolated here in this formula. So I could place all of these values, substitute them into the formula, directly into my calculator even, without having to do any intermediate steps. So let's see what that looks like if we just place these values or substitute these values in where they go in the formula. So check behind me. Did you get the same thing when you substituted these values? Now, even though that looks really messy, fractions within fractions, our calculator can handle all of this. Remember, the reason why we can type all of this directly into our calculator and obtain a final answer is because A is the question, and A has already been isolated in this formula. So let me show you now how to type this into your TI-34 calculator. So let's start with R. We're going to open up a parentheses and another set of parentheses. Let me move this just a little bit more here. Okay. Actually, let me delete one thing. I'm sorry. We'll open up a parentheses, and then the next thing that we have here inside this parentheses is a fraction. So let's go ahead and press the fraction key. In the numerator of that fraction, we start off with an open parentheses, 1 plus, and then another fraction. So let's press the fraction key again. I'm going to type in that decimal. Close that parentheses, and raise this to the 60th power. Move the arrow to get out of the parenthesis, out of the exponent, and then subtract 1. And at that point, I have everything that I need in the numerator of this larger fraction. So let's move down to the denominator. In the denominator is another fraction. So press the fraction key, and we'll enter the numerator and the denominator. And if we move out of all of this fraction all the way to the very end, we should be able to close the parentheses and see a large parenthesis. So that's this parenthesis right here. And at that point, we have the future amount. We would want to round this to the nearest cent. So here is our final answer. The future amount of this annuity is $6,616.74.